Today we are going to learn chain rule. Chain rule is used when we are trying to find the derivative of a function which is composed of multiple functions, which is a composition function. For example, f of g of x is equal to f of gx. It can be written as a function h of x. So h of x function is composed of two different functions. It can be composed of 3, 4, or 5 different functions. So first we're going to identify, we're going to look at a few examples and we're just going to try to identify which one is the outer function and which one is the inner function. So here's a couple of examples. In the first one, the outer function is x to the power 2/3, inner function is 1 plus x to the 4th. And that's how we get the composition function. So this is f of g of x. Outer function is f and the inner function is g. And number 2, the outer function is fifth root of t and the inner function is 1 plus tangent t. In next one, the outer function is 3 cotangent theta and the inner function is n theta. And outer function is e to the power x, inner function is x squared. Outer function is tangent x, inner function is sine x. Outer function is cos x, inner function is 1 over x. It's very important to be able to identify which one is the outer function, which one is the inner function. Only then we can apply the chain rule correctly. Okay, next, how many functions make up the following composition? So look at it carefully, pause for a minute and see how many functions do you see in here. I see 5 sine theta and then the radical square root of x and cos x and then cotangent x and then pi x. So 5 total functions are here, 5 functions, 5 total functions. Now, product rule, we've talked about fg prime is equal to product prime is equal to product of f and g prime would be equal to f g prime plus g of prime. First function times derivative of second plus second times derivative of first. We also recall the quotient rule, low d high minus high d low over low low. Chain rule says if you are trying to find the derivative h prime of x of a composition, then it is going to be, say 3-4 times derivative of outside function evaluated at the inside function times the derivative of inside function. So derivative of outside function evaluated at inside function times the derivative of inside function. There's another notation called Leibniz notation. We can say y is f of u and u is g of x. So inner function would be u. You have another function of x inside the f. Then we can say dy dx would be dy over du and du dx, product of dy du and du dx. Derivative of y with respect to x is equal to derivative of y with respect to u times the derivative of u with respect to x. When you're doing the homework, it doesn't matter which notation you use, which formula you use. I would be using derivative of outside function evaluated at inside function times the derivative of inside function, and you keep on doing that until you reach the innermost function. Okay, we're going to evaluate some functions here where we have a composition function. So here we have a square root. It's not square root of x, it's something more than x. So this is not square root of x, it's something more than x, and the more is your inner function. So my inner function is 4 plus 3x, outer function is square root of x. What would be the derivative of outer function? What is the derivative of square root of x? Just so that you recall, we can call it as if my y, so I'm just doing another example. This is nothing to do with this problem. To show you, if you recall the 1 over 2 root x, that is the derivative of square root of x, because you have x to the power 1/2. 1/2 comes in the front and then you reduce the power by 1, which becomes negative 1/2, and you can bring it down. So this, when I do the derivative, it would be 1 over square root of 4 plus 3x. Think of it like an x. It is something. Derivative of square root of something is 1 over 2 times square root of that something, and here something is 4 plus 3x. So derivative of outside function evaluated at inside function, that's what we just did. Now we're going to do times the derivative of inside function times the derivative of inside function. What is the derivative of 4 plus 3x? It's going to be 3. So y prime is 3 over square root of 4 plus 3x. Next, we have y is equal to tangent of sine x. So derivative of outside function evaluated at inside function. So we're going to think of tangent of something. What's the derivative of tangent of something? It is going to be secant square of something. So secant square sine x times derivative of inside function, which is going to be cosine x. Secant square sine x times cosine x. Okay, secant square sine x times cosine x. I'm going to write secant square sine x times cosine x. Next, we have y is equal to e to the power square root of x. Now, square root of x, it's not just e to the power x. It's something more than x. It's square root of x. So, y prime would be e to the power x times derivative of square root of x, which is 1 over 2 root x. So, it turns out to be e to the power square root of x divided by 2 root x. So e to some power derivative remains the same, e to that power, and we will have to multiply with derivative of inside function, which is square root of 2 in this case. See a couple more examples. Y is equal to sine 4x. So y prime would be cosine of 4x times a 4, derivative of inside function. Next, sine 1/2 of x, that would be cosine of 1/2 of x times 1/2, derivative of inside function. Next, y prime would be, cosine is an even function, so if you want to make your life easier, you can pull out the negative and just think of it like y is equal to cosine of 8x. That is okay. So y prime would be equal to negative sine of 8x times 8. So negative 8 times sine 8x. You can write the 8 in the front. Negative 8 times sine 8x. If you did not pull the negative out, if you want to look at it as y is equal to cosine of negative 8x, then it is going to be, you could leave it negative, derivative of cosine x is negative sine x. That is correct. So if you leave it like that, then derivative of cosine is negative sine negative 8x, and sine is an odd function. You can pull the negative out, and it is also multiply with the 8, don't forget that. So negative 8 sine 8x, and you can pull the negative out, and the negative inside would become sine of 8x. So now leave it like that. Okay, leave it as y is equal to cosine of, if you want to proceed with the way it's given, then you can also do y is equal to cosine of negative 8x. Derivative of cosine is negative sine negative 8x times negative 8, right? Y prime would be equal to, so if sine is an odd function, the negative inside can be pulled out. That would make negative 8 sine 8x. If you pull the negative out, the negative here and here will become positive, but the last negative in front of 8 will stay, and that will still be the same that we got last time. Y prime would be negative 8 sine 8x. So you could go ahead and change the cosine negative 8x into cos 8x. So you could also say y is equal to cosine 8x, and then y prime would be negative 8, because the derivative of cosine is negative sine. Y prime would be negative 8 sine 8x. So both ways you get the same answer. You can write it however you want. Several more examples of chain rule. Y is equal to cosine of x squared. Which one is the outer function? Outer function here is x squared. Inner function is cosine x. Again, say it few times. Derivative of outside function evaluated at inside value or inside function times the derivative of inside function. So derivative of x squared would be 2x, and in this case my x is cos x. It's not just x, something more than x. It's a cosine x here. So 2 cos x times derivative of inside function, derivative of cos x is negative sine x. So it turns out to be negative 2 sine x cosine x. Now if you recall, this is a trig identity. Sine x, 2 sine x cos x can be written as sine 2x. So either way should be correct. Y prime, we are looking for when y is cosine of 3x squared. The outer function is cos x, inner function is 3x squared. Okay, so y prime is going to be negative sine, derivative of outside function evaluated at inside function, negative sine 3x squared times 6x. So y prime is negative 6x sine 3x squared. All right, next we're going to look at more examples of chain rule. f of x is 1 plus x to the 4th raised to the power 2/3. So we talked about this problem in the beginning. We identified which one is the outer function, which one is the inner function. Outer function is x to the power 2/3. Inner function is 1 plus x to the 4th. So how do we find derivative of x to the power 2/3? We bring the exponent in the front and we reduce the exponent by 1, which is 2/3 minus 1. And then, so this is what we did. We did derivative of outside function, evaluated it inside function. That's what we just did. Now we're going to multiply with derivative of inside function, which is going to be 4x to the 3rd power. So let's go ahead and simplify and clean up a little. Oh, nope. That's not the coefficient. So forgive me for that. That's going to be 2/3, and that was 4x to the 3rd. Okay, so that turns out to be f prime of x. We can write it as 8 over 3, 1, 8x to the 3rd over 3, 1 plus x to the power 4. 2/3 minus 1 would be negative 1/3. Negative 1/3. Okay, and that's going to be our solution in this case. All right, let's check out more examples. We have 8 over 3, x to the 3rd, 1 plus x to the 4, negative 1/3. Perfect, and that should be my derivative for this function. F prime of t, my outside function is 5th root of x. So derivative of 5th root of x is, think about 5th root of x. How do you find the derivative? It doesn't have anything to do with this problem, but I'm just asking you to think about its derivative. It's not the 5th root of x, it's something more than x. That's why we need to use the chain rule. So derivative of 5th root of x would be 1/5 x to the power 1/5 minus 1, right? Now my x is actually, or this is a function of t, 1 plus tangent t, 1/5 minus 1, and now we need to multiply with derivative of inside. Derivative of tangent t is secant square t. So f prime of t is 1/5 1 plus tangent t. 1/5 minus 1 is negative 4/5 times secant square t. And that's it. That's the derivative. Okay, let's see. Next we have y is equal to x to the 3rd plus 3x plus 9 times negative 4 raised to the power negative 4/3. Y prime would be negative 4/3 x to the 3rd plus 3x plus 9 negative 4/3 minus 1 times derivative of inside function. The derivative of inside function is 3x squared plus 3. Okay, we can pull out a 3 from, so it's negative 4 times 3 x squared plus 1. So I just pulled out a 3, factored a 3 out from here because I see I'm able to cancel it. Divided by 3 times x cubed plus 3x plus 9. That would be negative 7/3. Cancel out the 3's here. So negative 4 times x squared plus 1. X cubed plus 3x plus 9 times negative 7/3. And that's our derivative in this case. That's going to be our derivative. 3x squared we pulled out, so x squared negative 4x squared plus 1 is correct. X squared, that is perfect. All right, this is a 7. Next we have f of x is equal to e to the power x squared. Derivative of e to the power x squared is e to the power, e to some power derivative is e to the same power times derivative of inside function, because you're not dealing with just e to the power x, something more than x. It's x squared. So we'll multiply with derivative of inner function, which is x squared. 2x e to the power x squared is the derivative in this case. Next, looks like we would have to do product rule and chain rule both. So we're notching it up, and now problems will be getting a little bit harder. So y prime, let's go ahead and use the product rule. E to the power negative 3x, first function stays as it is. What is the derivative of sine 7x? That's going to be cosine of 7x times a 7. Plus, second function stays as it is, times derivative of first function, which is e to the power negative 3x times negative 3. So my derivative in this case, 7 e to the power negative 3x cosine of 7x minus 3 e to the power negative 3x sine of 7x. If you want to factor out e to the power negative 3x, you can, or you can just leave it the way it is. Again, product rule and quotient rule here. So y prime would be x squared times derivative of cosine 1 over x. Derivative of cosine 1 over x, you can do it on a scratch space if you need to. Derivative of cosine 1 over x would be negative sine 1 over x times derivative of 1 over x, which is x to the power negative 1. That's going to be negative 1 x to the power negative 2, so negative 1 over x squared, plus cosine of 1 over x times derivative of x squared, which is 2x. Now we're going to write it neatly here. I'm going to use a different color so we can see it properly. The negative and negative will become positive, and I can also cancel out the x squared and x squared. So that's going to be sine 1 over x, it's going to be positive, plus 2x cosine of 1 over x. Sine 1 over x plus 2 x cosine of 1 over x. Okay, and that looks good to me. Let's look at a couple more examples. Yeah, number 16. G of t is tangent of 5 minus sine 2t. So g prime of t is, remember, derivative of outside function evaluated at inside function. So inside is whatever you think of it, like something like x. It's not x, it's something more than x, but it remains the same. Tangent of something, derivative of tangent of something is secant square of something. So it's going to be secant square of 5 minus sine 2t times derivative of inside function. Derivative of 5 minus sine 2t would be negative cosine, because the negative in the front will stay, negative cosine 2t times 2. So this turns out to be negative 2 cosine 2t secant square 5 minus sine 2t. All right, next we have number 17. Y is equal to sine of cos of sine x. So we got three functions here. Start with the outermost function. Okay, when we do the derivative, be careful. We have three functions here. So derivative of outside function evaluated at inside function. Derivative of sine of x is cosine of x. So it's going to be cosine of evaluated at inside function. So I'm not changing the inside function at all. I just did the derivative of outside function. Now I'm going to multiply with derivative of inner function. What is the derivative of cosine of sine x? Derivative of cosine of something is negative sine of that something. Negative sine of that something. So it's going to be negative sine times sine x. Not negative sine times, but negative sine of sine x. Negative sine of sine x. Now we're going to do the derivative of innermost piece, which is the sine x. Derivative of sine x is cosine x. So if you want, you can pull out the negative in the front, negative cosine x, and then cosine of cos of sine x, and then sine of sine x. That is our derivative in this case. Several functions involved. Another one, cos cube x plus cos x cubed. So you really need to be careful here, your outer function and your inner function. Cos cube x is not same thing as cos x cube. So cos cube x is same thing as cos x to the third power. Okay, your argument is not raised to an exponent here, but if you raise your argument to an exponent, you will get cos x to the, so this is not equal to cosine of x to the third. It's not the same thing. Okay. All right, so let's go ahead and figure out our outer functions and our inner functions here. So which one is the outer function? Which one is the inner function? For this piece, your outer function and your inner function, your outer function and your inner function. So for this piece, your outer function is cos x, inner function is x to the third. For this piece, outer function is x to the third, inner function is cos x. Okay. And you can go ahead and do the composition of f of g and then see if you get this function back. So when I do f prime of x, cos cube x is going to be 3 cosine of square x, 3 cos square x times derivative of inside function, which is negative sine x. 3 cos square x times negative sine x plus cosine of x cubed would be negative sine of x cubed, negative sine of x cubed times 3x squared. So a little cleaning up, I can pull the negative out. Negative 3 cosine square x sine x minus 3x squared sine of x to the third. And that would be our derivative in this case. Let's see more examples. Square root of x over x squared plus 9. We do need the product rule and the quotient rule and the chain rule here. Why quotient rule? Because you have x over x squared plus 9. Why chain rule? Because you don't have square root of x. You have something more than x. Think about, how do we evaluate derivative of square root of something? Derivative of square root of x is, you should memorize, it's used a lot. It's 1 over 2 root x, because you can pull out derivative of square root of x is 1 over 2 root x, because you can pull out the, let me write it on the side here. If y is square root of x, y prime would be 1 over 2 root x. Why do we do that? Because x to the power 1/2 comes in the front, and then we reduce the power by 1, and that becomes a negative 1/2 exponent for x, and we can bring it to the denominator and make it positive. F prime of x would be 1 over 2 square root of x. So in this case, I'm going to have 1 over 2 square root of x over x squared plus 9 times derivative of inner function, which is x over x squared plus 9. Now, if I write it properly, this is a complex fraction. I can write it as x squared over 9 over square root of x and 1 over 2. And derivative of x squared plus 9 in the denominator and x in the numerator would be low quotient rule, lower d higher, lower term times derivative of higher term minus higher terms times derivative of lower term. Okay, let's go ahead and clean up, multiply, and see where does it take us. F prime of x turns out to be square root of x squared plus 9 square root over 2 root x, and then x squared plus 9 minus 2x squared. X squared plus 9 minus 2x squared over x squared plus 9 to the second power. Okay, cleaning up, because we have we have x squared plus 9 to the power half in the numerator, x squared plus 9 to the power 2 in the denominator. So I'm going to take care of that. We also have like terms here that we can combine. So we're going to do something about these two terms, and we will also combine the x squared and negative 2x squared. Okay, f prime of x, all we are doing is cleaning up. We're done with the problem. We're done with the chain rule, but just writing it a bit neatly. Power 1/2 minus 2 over 2 root x times x squared minus 2x squared is negative x squared plus 9 over x squared plus 9. We have already taken care of this denominator, so this is gone from here. Negative x squared plus 9, there's nothing in the denominator. 9 minus x squared, or negative x squared plus 9. So that turns out to be, we can write it as, finally, f prime of x is 1 over 2 root x. I'm not going to write it 1 over 2 root x. I'm going to put 9 minus x squared times, this is positive, 9 minus x squared, there's no negative here, x squared plus 9 divided by 1/2 minus 2 will be negative 3/2, and that's our derivative here. That's our derivative. All right, next example. Y is equal to e to the power cos x plus cos of e to the power x. Well, if you look carefully, we do have a composition functions here, and we are doing sum and difference of two functions. So I don't have to worry about product rule or quotient rule, but I would have to find the derivative of individual pieces and then add or subtract them together. E to the power cos x, derivative of e to the power x is e to that power, whatever that is. In this case, it's a function of x. It's not just x. If you have e to the some constant power, that is going to be a constant, and the derivative will be 0 in that case. E to the power cos x times derivative of inside function, which is negative sine x. And derivative of cosine of something is negative sine of that something, which is a function of x. Negative sine of something, and we will multiply with derivative of inner function, which is e to the power x. Cleaning up, so it turns out to be negative sine x, e to the power cos x, minus e to the power x, sine of e to the power x. And that's our derivative in this case. let's check out more example. Cosine of t e to the power negative 2t. Well, this one, again, we do have to use the chain rule and the product rule inside because we have product. So what is derivative of cosine of x? It is negative sine of x. In this case, we don't have x. It's something more than x. So remember, the derivative of outside function evaluated at inside function. Don't change the inside function. Leave the inside function alone. So negative sine t e to the power negative 2t. Now we're going to multiply with derivative of inside function, which is going to be, we have to use the product rule here. So t times derivative of negative first function times derivative of second function. Derivative of e to the power negative 2 is negative 2t, is e to the power negative 2t times negative 2, plus second function times derivative of first, which is just going to be 1, because derivative of t is 1. So negative sine t e to the power negative 2t times negative 2t e to the power negative 2t plus e to the power negative 2t. If we want, we can pull out e to the power negative 2t all the way in the front, and then negative sign at the front, and then we have sine of t e to the power negative 2t, and then we also have to multiply with negative 2t plus 1. We can write this function like this, and make sure you make the distinction that this is not a part of your argument for sine. That's why I put the product sign in the middle. This is not a part of your argument for sine. I would have put a bigger bracket if it was. Okay, one more example. The last example we have here. Oh no, we are leaving the 23rd. So I'm going to erase problem number 22 and go ahead and work on number 23. So I got more space. Okay. All right, so start with, we want to find y double prime in this case. Okay, so that's going to be a little more work. So let's start by finding the y prime. Sine of x squared e to the power x. It's going to be cosine of x squared e to the power x times derivative of inside function, which is x squared e to the power x plus e to the power x times 2x. Okay, cosine of x squared e to the power x times x squared e to the power x plus 2x e to the power x. Okay, now we can use the product rule here. So we can pull out e to the power x, and inside would be x squared plus 2x, and then we have cosine of x squared e to the power x. Now again, I'm going to do second derivative because that's what the problem was asking from me. It did ask me to find the second derivative. So when we do second derivative, we would have to use a product rule and chain rule at the same time. So product of three functions: first function, second function, and third function. So I'm going to leave the first and second as it is, multiply with the derivative of third. Derivative of cosine is negative sine, so I'm putting the negative in the front. Negative sine of x squared e to the power x times derivative of inside function, which is x squared e to the power x plus e to the power x times 2x. Plus, let's leave the second and third as it is and find the derivative of first function, which is just going to be e to the power x. So that makes my life easier. And now let's keep the first and third as it is and find the derivative of second function, which is 2x plus 1. Okay, so that's my derivative in this case, and I'm going to leave the simplification part for you. Check if there is anything that can come out, any common factors in there. If not, then we would just write the entire thing. Here's one more example. We have multiple functions here. Square root of 1 plus square root of 1 plus square root of x. So we got several different functions here. I'm going to go ahead and write it as 1 plus square root of 1 plus square root of x. Let me rewrite it. Whenever we are doing the derivative, it's always nice to look at the function using the exponent instead of the radical. So I didn't change anything. Instead of the outer radical, I put the exponent 1/2. That's all I did. So let's go ahead and find the derivative. Y prime would be derivative of something raised to the power half, or x raised to the power half is 1 over 2 square root of x, which is going to be square root of 1 plus square root of 1 plus root x times derivative of inner function. What is the inner function? Here is my inner function. What's the derivative of 1 plus square root of 1 plus root x? That is going to be 1 over 2 square root of 1 plus root x times the derivative of innermost function. My innermost function is 1 plus root x. Derivative of 1 plus root x is 1 over 2 root x. Okay, and that's looks like that's all we would have here. We can go ahead and write y prime as 1 over 8 square root of x times square root of 1 plus root x times square root of 1 plus square root of 1 plus root x. And that's our derivative, the final answer in this case. So we looked at a lot of examples of chain rule. Say it a few times, memorize this, that whenever you're applying the chain rule, first of all, when do you need to use the chain rule? When you're finding derivative of not x, it's something more than x. Your inner function is something more than x. And also memorize the chain rule that it's derivative of outside function evaluated at inside function times the derivative of inside function. And we keep on doing that until we get to the innermost function if you have more than two functions. That's all for this video.